Hi and welcome to this tutorial. Today I will be showing you how to create realistic gravity inside Unity. So the way we will do this is we will have two scripts, one that calculates the gravity and one that you attach to all the objects you want to have gravity applied to. So first let's create those two scripts. One we call gravity object, and the other one we call gravity calculator. Let's start with the gravity object script. So open those, and inside of here we will want to have a few variables. The first one is our rigid body. So the public rigid body RB, and then we will also want to have two vector 3s, one for an initial force we can apply at the start of the game to have an orbiting behavior, and another one that we apply at the end of each frame. So get a public vector 3 force, and then public vector 3 and frame force. Okay, and we can hide this one from the inspector. And now we can just create an awake function and declare the rigid body. Rigid body. Okay. And let's create the list next in the gravity calculator script. This list will keep track of all the gravity objects in the scene. And this will be just like a static list, which will help with performance, and it means that you don't have to call the get all gravity objects function every frame of the game. So just get a public static list of type gravity objects, and then declare a new list. Okay. Like this. So what else do we need? We need a float for our gravity power. We don't want to be using the normal gravity constant since that value is way too low, and I think we would need double precision floats. Gravity power. And set this to a base value of 1, and we can have one of those cool sliders inside of our game to change the gravity value in real time. And then we can also slow down or speed up time with a time scale. Set this also equal to 1, and then we can have this as a range, and be sure this value can never reach 0 or else your game will just stop or freeze. And if you go up to the max value and have a lot of objects in your scene, it will also start lagging, so watch out with that. So what should we do now? First, add the objects to the list we created on awake. So since this is static, we can just call it directly. We don't need a reference to the exact script. So gravity calculator dot g objects dot add, and then add this. Good, like this. And let's head back into the gravity calculator script and create the actual functions we need. So one function is for creating the gravity, not the gravity, for calculating the force that is applied through the gravity. So just call it calculate force, and it will take in 4 different variables, 2 gravity objects. Let's just call one cause and the other one target. And then we can also have 2 rigid bodies here. One is the cause RB, and the other one is the target RB. Good. Now we will have to calculate the force of the gravity. So to do that, we first have to have the vector between the 2 objects, and we will call this one direction. So get a vector 3 direction, and this is then equal to the cause RB dot position minus target rigid body position. Okay, now we want to check if that value is 0. Vector 3 dot 0, and if it is, for whatever reason, we just want to, we can do it like this, return. And of course we need to have double equals here. So if direction is not equal to 0, we can continue with our calculation, and what we will have to do now is calculate the force. So the force is going to be a vector 3 value called force, and it is equal to the gravity constant times the mass of both bodies divided by the distance between them squared. So let's just first get the gravity power. So this is our gravity constant, gravity power, and then add multiply the 2 masses of the objects. So cause rigid body dot mass, and then also target rigid body dot mass, and then divide all this by the distance between them squared. So to do that, we will get the math f dot power, and then the distance between them is of course the direction and then the magnitude, and we want it to the power of 2. So then, as you can see, this would all add up to be a float, but we want it to be a vector 3, so we just have to multiply this by the direction we want the force to be applied to in. So the direction we want the force to be applied to in is of course our direction vector, but we first have to normalize the vector. And we just do that by typing direction normalized. Okay, now we have our force vector, and now we can just apply our force vector to both of the bodies. And we already created a variable for that called end frame force. So get the target dot end frame force, and then add the force, and also get the cause dot end frame force, and then subtract the force. Otherwise the objects won't be moving towards each other. So two more things we have to do here. One is to call this calculate force for all the objects, and then one to add the force here at the end of the frame. So let's create the loop first that calls the calculate force function for all the objects, and we can do this in fixed update. So just call fixed update, and in here we create a for each loop, and we get all the gravity objects. Let's call those calls object inside of our collection, which is gravity objects. Now in here we loop through all the other bodies, so this loops until gObjects.count. Okay, and inside here all we do is call the calculate force function, which takes our 4 input parameters. So the first one is the cause gravity object, which we already have defined here. So we can just input this here. Cause object. Target object is our gravity objects number I. And then the cause rigid body can be defined here. So we just define a rigid body cause RB, and this is equal to cause object dot rigid body. And then we can just add this in here, and don't forget the semicolon. So cause rigid body, and then the target rigid body, which is gravity objects I dot rigid body. Okay, and as some of you may have noticed, the way we do it now will mean that some of the objects will have the force applied to them twice, and to stop this we can just create a loop counter here. If you don't understand, it's no problem, you can just copy this. So get the loop count and increment it here by 1. And then instead of starting at 0 all the time here, just start at your loop count. Okay, good. So now that we have all this set up, we can call the add force function at the end of this loop. So just call add force, which is a function we haven't created yet. And then we can also set the time scale to the one we just selected. So get the time scale and just set it equal to our own time scale. Then we create the add force function. All this will do is just loop through all gravity objects. Temp object in our gravity objects list, and then just call temp objects.add force, which is also a function we haven't created yet, but we can create this one now. So go back into the gravity objects and create a public void add force function, and inside of here we will check if end frame force is not equal to vector 3.0, Then we will just get rigid body dot add force and frame force, and then be sure to set the end frame force back to 0. Good. Now we can delete the update loop, and I think we are ready to try out the script. Okay, let's head back into the game and create, let's say, a cube and a sphere. So cube, don't forget to add the gravity object component and also add a rigid body. Uncheck the use gravity, masses, whatever you want it to be, and then add the gravity calculator to something permanent in your scene. I would just add it to the main camera. So here we have a cube, and then we can just create a ton of cubes. Why isn't this duplicating? Okay. Okay, now let's play the game. And as you can see, they are all moving towards each other. And let's see if our time scale increases the time. And stronger gravity. And we can also do negative gravity. Let's see if they still pull together. Yeah, looks like everything is working the way it should. Now, another thing we can do is give the cubes or whatever bodies you want to an initial force. And as you see, we already created the initial force vector. So all we have to do now is just in the start function call rigidBody.addForce, and then just take the initial force multiplied by the mass. The mass is rigidBody.mass, and this is supposed to be a force mode impulse. Okay, now to try this out, we can give this cube speed and this one an insanely high speed and see what happens. And as you can see, they do have an initial speed, so everything is working fine. And let's make something orbit around another object. So we can just delete everything but two objects, and let's just center this one to the middle, make it way bigger, let's say 10, and increase the mass, and then have this object say like 60 units away, and mass is okay, and then just give it an initial force of say 3. And as we can see now, this object is not supposed to have any force. If we increase the speed, the one cube is orbiting around another cube. And as you see, the one in the middle is wobbling a bit, because it is of course also getting affected by the smaller cube. If you don't want this to happen, just click the is kinematic button here. And as you also saw, the orbit was elliptical. So if you want the orbit to be perfectly circular, you could either just guess the values until it is almost perfect, or you can use a formula and just get out the calculator. The formula is you take the mass of the big body you want to orbit, multiply it by the gravitational constant, and then divide it by the distance between the two objects, and then take the square root. So we can do just that. Our gravity constant is 1, and this cube has a mass of 1000, and the distance here is 60. So we can take 1 times 1000 divided by the distance, which was 60, and then take the square root, which gives us 4.08. So if we now apply a force of 4.08 to this cube, it should orbit perfectly around the bigger cube. So to visualize this, we can just add a trail renderer, give it a default line material, change the color to whatever you want to, just make it a bit nicer. 10. And then increase the time. So let's see if it works. Increase the time scale. And as you see, it is a perfectly circular orbit. You can also see the values here almost reach 60 again. So of course it's not going to be super perfect, but it's usually good enough for most purposes. So that's all I will be doing in this video. If you want to, there's a bunch of other cool stuff you can do too, like you can have a body orbiting a body orbiting a body, but I will just let you figure that out for yourself. Otherwise this video will be way too long. Okay, bye.